Hey, what's up, Chin here from Code and Quick Tips. Today was the promised video on the actual implementation of a component-based design approach. We discussed the design approach on a component-based entity system in the last video, and in that video I want to show you how you can actually implement an entity system framework based on components in your Slick2D game. We will use the Artemis entity system framework for that, which is a pre-built Java entity system framework which works perfectly fine and which is a super good, a super fast implementation of an component-based framework. To start off, you will have to install the Artemis jar to your Slick2D project. You can get all the files on the official website of the framework, and I will link to the download link, so just go down there in the description and grab yourself the Artemis jar and the Artemis source jar. So you also get the source files and you actually can see where your error is and you get some explanation on the methods. To start off, I just created an empty project as always. So for that, here we go. I created an empty project as always, just with a blank window and some grid to actually see the movement better. It's a simple Slick2D project, so nothing too fancy here. To start off, you will actually have to drag in your Artemis and your Artemis source jar into your project, for example into your lib folder. And then you will have to actually bind it to your project. To do that, you right click your project folder and then you click on the properties down here. You go to Java build path, to libraries tab up here, and you click add jars. Then you navigate to the folder where you just dropped in the Artemis jar and you double click it. It should appear in the list down here, and to add the source attachment you just tick that little box to flip it off, to make it bigger, and then you will be able to add the source attachment. To do that you double click on, add the source attachment and then go for workspace location. And for the path, go to browse and just select the source jar. With that we are ready to go and we have successfully imported the Artemis entity framework. So what will the Artemis entity framework do for us and what will it help for? Why is it helpful to use that instead of writing your own ones? Well, it provides us for the basic stuff that we need in a component-based entity manager. It provides us with a basic entity manager where every entity is empty and has only an ID. We can assign components to those entities and we can have systems to process those entities. So if you're a little confused now because I haven't mentioned systems in the theoretical video, Artemis is not a pure component-based system. It's one step further. It's a component system-based framework. What this is, it abstracts everything even a little more, which is can be bad and good. Some people don't like it. I personally think it's a good approach, and the best thing is performance-wise, the approach of a component system-based engine or framework is actually the way fastest way to go. That's why it's also implemented in a component system-based manner. You will see how that works out later on. As discussed in the last video, in a component-based entity framework, everything is based on components, and those components will actually define our game objects later on. So let's start and actually create a component. Why not? Let's start. Let's start with a really, really basic component. Therefore, just go and create a new class for the component. So if we say, what's the most basic thing every single entity will probably need, or most entities will need, it's a position in my opinion. So create a new class called a position. And here we can go and actually say our position is a component. To do that, just extend from the component base class, and that one is given, give a second, component. And that one should be given by the Artemis engine. And here we go. That's our basic position component. Well, it's empty right now. So here comes the first clue of a component system-based design approach. In a component system-based design approach, a component is raw data. A component does not do any logic. The component is only storing the data. For example, our position component would have a private flat x and y for the x and y position, obviously, but it won't process these positions. So it will only have the positions, but it won't actually do anything with those positions. So in a component, we only store the data. The processing on the data will then be done in a system that I will introduce to you in a few minutes. So let's start off with the position component. Obviously, we will add getters and setters to both x and y. We can auto-generate these to save some time. And we will have a constructor, so public position. Well, that's pretty simple. What we have here is, as I told earlier, a pure container for data. So we got the position itself and the position data, and we can set these values, and we can add some additional functions that could help us in here. I'm just gonna get some in here. For example, set position, add x, add y. So that will help us later on. But as you can see, it's pure processing the data. It's not doing any logic, and that's the base rule here. So how do we now create an entity and apply that component to it? So let's go back into our main game here. And what arithmetics use to manage all components is called an word. So private word. Here we go. And import it, and say you import the arithmetics word here. So we take it from the arithmetics framework. We will init our word equals new word in here. It's hard to type and talk. So we init it in our init method. That's what you need to do. And after that, we would then actually modify the word to fit our needs. And after doing some stuff to the word, so do stuff, we will do that later on. After that, we need to initialize it. And after we've done that, we can actually use the word. And to do that, we will have to do both. We will have to update the word, and we will have to set a delta for the word. So give a second. If we go to the update method, we can say word.setDelta. Here we'll be able to set a delta time for the word that we can then later on use when processing our entities. Our delta time in Slick2D is counted in milliseconds, but here we want to go for our delta divided by 1000, that's 0. So we got our delta actually in seconds, so in 0.1 second, for example, for one delta. With that method call, we will say the word. In the next processing call, the delta time will be set time, and we can access the delta time. So that's pure handling of variables. And here up in the render method, I would do the word processing. What we will do here is word.process. If that method is called, our word is actually processed once. So we run all our logic once if we call that method. So if we start it right now, it will do nothing as we haven't created any entities, and as those entities aren't doing anything. So let's get started and create an entity, shall we? To do that, we will have to use our word object after it's initialized and say word.createEntity. That will give us a new entity object, and this entity object then can be modified, and after we finished modifying our entity, we say entity.addWord. So with that call, our entity will then be actually in the word. So you might ask now, well, our entity is empty, it doesn't do anything. That's true, so we are using components. Let's add a component to our entity. To do that, we say e.addComponent, and here we can just say new position. As our position is a component, that will work perfectly fine, and it wants like some position, as we actually have set that in the constructor. So what we do here is we initialize an entity, we add the behavior of a position to it, so it has now actually a position in our world, and at the end we say, yeah, we're finished with that entity, push it to the world, and at that moment it will exist in the actual world. If we start now, again, we won't see anything. Quite sad, huh? Well, it is because we haven't created any logic yet. Our position is pure data. For the logical component, we will actually have to do an entity system. Right now we can't see our entity, and for debugging purposes it can be good to create a debug rendering system that will basically what will it do? It will basically draw dots at every entity's position, at every entity with a position. And with that we can then later on track where our entities are, because right now they are poor data and they have no visual representation. So let's get started and create some logic for our actual entity. Also logic is done in systems. So let's create our debug rendering system. I will call that debug point renderer, and what that will be is it will be an entity system. To make it an entity system, you will say extend entity system. At that moment you will see an arrow because we will need some methods. So click here, we will need a constructor, and the constructor is really the interesting thing of the actual entity system. So what will the constructor take? It will take a thing called an aspect. Well, what's an aspect, you will ask me now. An aspect will define, I will quickly get it in here, that here is an aspect. So let's get quickly over those few lines of code and tell you what those do. So we have our constructor and we call our super constructor. Our super constructor will basically take arguments in terms of when will this system be applied. So at the moment we give our super constructor an aspect that says get aspect for all position.class. What that says basically is we want our entity system will run on all the entities that will have a position component applied on it. So every single entity in our world that has a position applied to it will be processed in this entity system. And if we now add some methods that we still need, here we go, you will see a check processing method. You will want to say it return true. What that does, it basically says if the entity system is active. So if that returns true, the entity system will run and will update. And that's a really interesting method here. It's a process entity method. It will give us an immutable bag of entities. It's basically an array of entities. And what that will do is it will give us all the entities that have at least the position component on them. So every entity with a position component on it will be processed in here. So now let's process those entities. First of all, how do you process all the entities? You will do that with a simple for loop. So we go for for loop and I equals 0. S equals entity size. Yeah, here we go. We say I equals 0 and let's grab that out. That might be a little confusing for you. So S is actually the size of our entity array. So we got the amount of S is the amount of objects we have in our entities array. And then we basically loop through the array and we can say entities.get and send the number. And with that we will be able to get every single entity. Now the next step is how can we get the position component out of the entity we just got here. To do that we will need a thing called a mapper. I will just quickly add it in here. So what is a mapper? I just added that line of code. What this is, it is a component mapper that will map positions. And I call it PM, position mapper. What that will do is a component mapper can do basically, let me, entity E equals. So here we got our entity, and if we now want to get the position out of that entity, we basically say PM position mapper dot get, and we handle it over an entity. That will return a position component, and we can then save the position component in a variable and use it to draw. So what we do here is we use a position mapper, which we created up here, a mapper that will get a position component, and through that we will get the position component out of our given entity. So to actually debug draw, we will need the graphics context, and I will just make it statically available here, as that's the easiest way to somehow manage that. So I will say in the game class, create a static variable, which will be the game container, and in the render loop, I will just say game container equals GC. So we will update that every update loop. And with that, we will have the game container statically available. as there is, as that's my way to handle over, or a quick way to handle over it to our actual systems. In our actual debug rendering system, we just loop over the entities right now, but we don't draw them actually. To do that, we will need a graphics object, which we can now get. I just do that for debugging purpose. In the game later on, you can do it on a different way. But right now, that's good enough to get the graphical context in the debug point rendering system. So now we have the G here, the graphics, and we can actually draw our, what we want to draw. So what we will do here is we will fill an oval centered at the position of our entity. Some basic drawing code. And before we draw, we will set the graphics color to white. So we will draw white ovals or white circles at all the positions we have entities at. If we now run, nothing will happen because we haven't added the system to the actual world now. And here is where the do stuff part comes. After you created the world, you usually want to add systems to the world. All the systems that are applied on the world will run and will actually execute some logic. So we want to say world.set system. Here we go. And here we can handle over a new, give me a second, new debug point renderer. And what that will do is, now our world knows that we have a debug point renderer, and now it will take our created entity and handle it over to the debug point renderer. We will catch its position, and draw it. So if we run it, ta-da! We can draw a dot. And that after, well, 60 minutes of tutorial. Not too good. But I created some other classes that you might like. So you can see, at that point you can actually see why I love that system. So let's create some new properties for our entity, as just in position is boring. Let's say we want to move that position. So what moves an object? Well, basically a velocity. So I'm gonna create a velocity component, and just to speed that up a little, I've prepared that. Our velocity component is basically the same as our position component. It got an x velocity and a y velocity, and we will set velocity, and we will make a add x and add y. And it's pure data again. But what we can do now is we can create a little bit of a more complicated system. And I'm gonna introduce you to a second type of system here. So let's create a new class, which will be our movement system. Our movement system will do all the movement of objects. So if we create that, I'm gonna copy paste it in here again to save you some time and just go over the code. So what you will first see here, I first used an entity system. And here I use an entity processing system. The difference is, in the entity system, you will get an array with all entities, and you will have to loop over it manually, which is very efficient for drawing purposes, so we don't have to set the color for every drawing call again, or if we draw multiple images. That is really effective if we just go over an array. In opposite here, if we go for the movement system, we can use the entity processing system, and the big contrast here is it will have a process method instead, and this process method will be called for every single entity, so we don't have to loop manually, we can just loop, it will loop for us, and it will be called for every entity. So we will get every entity in here. And as before, I again have a mapper, a position mapper, and I also have a velocity mapper to get the velocity component. And for the aspect, here we say get aspect for all, and you can divide it with commas and create an infinite list. And I will say every object that will be handled to the movement system must at least have a position, so it can be moved somewhere, and a velocity, so it has something that it's moved with, like a speed that it's moved with. So here we'll get all the entities that have both a position and a velocity component. So in the processing, I get both, and I just update the give me a second. Yeah, here we go. And I just update the position, and I add the velocity times the delta time to the x position and to the y position. So that's a simple movement logic that you should know. And here comes our delta time handy. We just say world.getDelta, and here we will get the delta we previously set in here. So after we did that, you can see that we are pretty much finished with a movement system, as a movement system is really easy. And if we now want to create a moving entity, what we can do is go to our game, and let's say we create a second entity. So, a second entity, which will spawn at 200, 100, and we will add a second component to it, which will be the velocity component. And it will be like, I don't know, 100, 200, yeah, let's make it not that fast. So if we start now, we got two entities. Give a second. Oops, yeah, it won't work as long as you don't add the system to the world, so sorry for that. So we now have the movement system in our world, and as you can see, it will move the entity with a velocity on it, and it will process that entity. And the second entity has no velocity, therefore it won't be moved. And that's how cool it is. You just add a movement component to whatever you want moving, and it will work. Yeah, to give you like a quick overview, just at the end, what you can do. Basically, you create components for properties. Those components will contain poor data, and then you add systems to process them. Just to give you a quick idea of how quick you can create stuff with that with that system, or with that technique. Let's call it that way, with that technique. Here we have created a moving entity, and it took us really long. You might say, wow, it's ineffective, but you need to see you can reuse the position, the velocity component on every single project. And now you could go further and say, well, let's include more different processors. Here I got another really simple project where I added a physics object with some basic mass and elasticity as properties that an entity can have. And I got a system that will basically just bounce it off the walls and yeah, do that. And so I got a physics system and a physics object. You can obviously make this way more complex. But if I go for that, I can have a velocity, a position, and a physics object. And I have an image rendering component. So I got 4 components. And with those 4 components, I can create every kind of different effects. I can do a static image rendered somewhere. I can do let me start it again. I can have an object that moves with a constant speed. I can have physics objects, so you can actually recycle really a lot of that system here. And one thing I want to notice before I end that tutorial off is that we have only covered the basics. We have covered systems, and we have covered components, and we have covered the general use of the world object. Actually, Artemis offers you a lot more. It will also offer you different ways to handle groups of objects. For example, for a team-based game, it will give you different ways of tagging entities, of messaging between them. And those can get really handy. So have a look at the Artemis manual for them, because they're really easy to understand. But just with those basic functions, you should really be able to get a lot of stuff done and to get your game to a certain scale, because you can recycle a lot. You start by simple stuff like position and component, and it might take you first a little longer. But in the long terms, you can recycle them and reuse them, and you can do complex gameplay decisions later on, and it will work just fine. And that's a really, really great thing. Just to give you a quick notice, so what do we have here? We have different systems on the thingy, on the Artemis website, on the Artemis manual, and we got different group managers and so on. And those can be really handy, so have a look at them, and have a look at the site. In general, I really hope that I could show you why I love the component-based system and why it's used by all the bigger engines and also serious engines. It's used because it's so cool and it's so easy to use. So with that said, I really, really hope you enjoyed the tutorial, and I really, really hope I could help you to enchant your further project or your future projects. And I really hope that you got the concept. If you have any questions left, let me know in the comments. If you have enjoyed the video, please like it, that would help me a lot. And if you haven't enjoyed the video, please let me know why you haven't enjoyed it. Give me some constructive feedback. I always want to improve my videos. And if you enjoy my videos, then you should definitely subscribe, because I will get some more out that could definitely help you, will definitely help you in your future projects. And with that said, I really hope you enjoyed, and I will see you next time.